Thank you, everyone. Thanks for joining us today for our session on AIAIO training data. And basically what we're talking about is how top companies are creating training data and using training data. First off, I just want to introduce myself. My name is Christina Del Villar. I am the Global Head of Enterprise Marketing at Udacity. Udacity is an online education solution, and we focus mostly on in-demand skills. So a lot of you guys have taken some of our data science courses, self-driving cars. We also have AI and machine learning and deep learning, and we're coming out with some new ones on TensorFlow and PyTorch and C++, so a lot of new and exciting things that hopefully will help prepare people for the technology that's coming out. And so that's why this is sort of near and dear to me. I've been in marketing for the past 30 years, and I can tell you that when I first started, we didn't have access to data. We didn't have tools to basically run our programs. We didn't have anything that tied it all together. I had no idea who was reading my emails. I knew my mom was reading my press releases, and that was like all I knew. There was just no way to know what was happening. There was no way to sort of help marketing people prove the impact that their programs were having. And then obviously technology evolved, and I worked at Oracle, so I had access to some data there and some marketing tools, which is fantastic. Also worked on a lot of other startups, and like I said, now I'm at Udacity, where we're actually teaching AI, and it's great to kind of see the progression and what's going on there. So today, what I wanted to do was talk a little bit about where it's going, right? Like what's happening, and if you've been to South by before, a couple of years ago, it started off. We talked about what AI means, and then people were talking about AI application, and now it's gotten to the point where it's like, great, everybody has these initiatives, but like, what's the underlying component of it, which is the training data. So we really wanted to talk about that a lot today, which is what we're going to do. One of the things that I'm really excited to talk about really is like what kinds of, like you were talking about earlier, like what kinds of training data is available, whether it's purchased or whether you are doing it through client services, or whether it's like crowdsourcing or with HubSpot, whether it's user generated. There's so many different ways to capture and use this data these days, and we really wanted to talk a little bit about that. And so we're going to focus a lot on that. That said, I'm going to go ahead and we're going to start, and actually David is going to start us off and introduce himself.
Hello! My name's David Silver. I lead what we call the School of Autonomous Systems at Udacity, which is a group of programs that we teach around robotics and self-driving cars. I came to Udacity about 2.5 years ago from Ford Motor Company. Ford has a self-driving car team in Palo Alto, California that I worked on. And before Ford, I was a normal Silicon Valley web software engineer for about 10 years. Does anybody know what that red icon is? Buddy? Ruby? Oh, all right. Who else said Ruby? Yeah, heads up. Okay. A few years ago, I got really excited about self-driving cars, but I didn't have any background in automotive software or robotics, so I started taking classes online at Udacity and other places, and eventually I got hired onto the self-driving car team at Ford, and the folks at Udacity saw that and said, why don't you come to Udacity and build out for other people essentially what I had done for myself, a path to working on autonomous vehicles. So I've been at Udacity for the last 2.5 years working on that. We've had thousands of students take our robotics and self-driving cars programs, and many of them now work at a lot of the big robotics and autonomous vehicle companies you've heard of in the news, and we are very, very proud of them.
Excellent. Thanks, David. And we're going to have Rob.
Awesome. How's it going, everyone? I'm Rob. I'm the VP of Product at a new company called Knowable. We recently spun out from the alternative legal services provider, Axiom Law. And I joined Axiom about a year ago, which was about year 5 of their journey. They were about 20 years old. And those 5 years that I'm highlighting there are really the ones where they started discovering that there's a need to extract structured data from legal contracts, from the prose, from the written word at scale. And that helps decision makers in an M&A transaction or across really critical business units to interact with their contracts both at scale but also at the level of detail that they need without having to involve yet another lawyer. Prior to that, I was shortly at Intuit to help them with a machine learning driven recommendation program for add-on applications to their small business group. And prior to that, I had an exited company as well as I worked at an e-commerce and finance startup.
Excellent. Hector?
Hello, everybody. I'm Hector. I'm the engineer lead for machine learning at HubSpot, where I lead a group of around 20 engineers, and we cater all the machine learning for the company. HubSpot is the company that invented inbound marketing, which I'm pretty sure Christina knows a bit about. So marketing back in the days used to be done by throwing your message out and hoping that it sticks. So you could just blast your message. And these days, the new approach that a lot of people are taking, that we call inbound, is about creating content that is relevant to your customers and make sure that they can find it on their own terms. So because of that, it's much more data-driven, and because it's much more data-driven, machine learning and AI have a much more prominent position because we can use it for personalization, for optimization, and all that. Before HubSpot, I used to work at Google, where I was working on the anti-abuse team for Google Search. So making sure that we got rid of all the bad actors in search, all the web pages are not playing nice, are trying to cheat the system. Obviously, a lot of opportunity for machine learning there. Before that, I was working on fintech, a lot of repayment prediction, figure out if people can or will pay back credit. Before that, I was working on online gaming, where we could detect cheaters and bad actors. Again, a lot of opportunity for AI right there.
Who knew? Thanks, you guys. So we're going to get into some things, but first I wanted a show of hands to understand if you guys actually have some initiatives going on right now. So if you have an AI or machine learning initiative going on right now, go ahead and raise your hand. Okay, that's quite significant. What about folks who have one planned right now? How many of you are like in the dreaming phase? Yeah, okay. Excellent. No, so it sounds like, about a third of you guys already have some initiatives going, which is fantastic. So, perfect. So what I want to do is basically sort of level set, our definition of machine learning and AI and training data, so we're kind of talking on the same level here. So, Hector, can you go ahead and kind of walk us through that?
Yeah, absolutely. Just as an introduction, I think it's even before we talk about what machine learning is, it's important to know why we do machine learning. So AI is about making things smart, whatever that means, really. Before, until 5, maybe 10 years ago, machine learning was not the dominant way of making things smart. The way things used to be done before was with programming directly the rules that answer the problem. So if you were, for example, trying to make translation, more or less what you could do is code the rules of the grammar of one language, the grammar of the other language, the vocabulary of the other language, slang, exceptions, and all those nice things. Obviously, this thing takes forever, is super expensive, error-prone, and I have to say even boring. I mean, that's basically the reason why I never went that way. I find it boring. Machine learning is another approach. It's not new. I mean, these things from the 70s or maybe even 60s. But the idea of machine learning is that instead of telling the computer the solution, you tell the computer how to learn in general. And you create like a little brain in a way. And then you just throw a bunch of information to it and hope that it learns, which it actually does. So you, instead of taking all the rules of grammar for English and Spanish and teaching how that works, what you could do is you would teach it how learning in general works, and then show a bunch of English and Spanish. And for example, you would take all the Wikipedia in English, all the Wikipedia in Spanish, and get it to learn from there. So that's it's a much better way of learning in general, and that's the way that most of the companies do those kind of things today.
That makes sense. So we're going to move on to the KitKat example. KitKats explain.
Right. So yeah, let's talk about what training data is, which I guess is the core thing of our presentation.
By the way, sorry to interrupt you. We couldn't find any kittens, so we can't really do a true example between KitKats and kittens, but...
Yeah, it's probably not good PR throwing kitten around either. So yeah, training data at the end of the day, the only thing it is that what I just said. You first train code the brain, and then you give it a bunch of data. And what training data is that data. And generate a bunch of examples. And these examples generally are made up of two parts. One of them is what we call features, which is the things that you know about the problem at this point in time, and the label, which is the correct answer that you should have. So for example, in the image over there, you can see a bunch of handwritten ones, handwritten twos, and the labels could be like the correct answer, which is this is a 1, this is a 2, or a cat, or a Kit Kat, and this is a cat and not a cat. Yeah, this is what training data is. One thing that you hear all the time is that training data is the field of machine learning, which pretty much is, to be honest. Like, there are certain interesting graphs you can find online about the impact of data compared to the impact of having a good model, and actually the impact of data is generally, in most cases, it's much more evident. So the problem with this is that because what you really, really need is label data, you hear very often is like, I have millions or billions of data points. I'm sure you can do something with machine learning. Maybe, I mean, having more data is always good, but what you really, really want is those labels. And generating those labels can be tricky. Generally, it's very tricky. It's actually one of my main jobs. Like, I'd say my day job, more than creating models, actually making sure that we can gather those. So, for example, so we become very creative in companies to be at generating these labels. So, for example, you can imagine those numbers, which I'm pretty sure they're coming from MNIST, so it's coming from the US Postal. You have all these numbers, but you don't have the right answer for that if you are US Postal. So you would need to have somebody go there and go hand by hand. Okay, this is a 1, this is a 2, which is expensive and annoying. So you can create what we call feedback loops, which basically what it means is that you can leverage some process that you already have in your company to gather those labels. So for example, if you're a US Postal, you could take the actual postman that is going to have to go around and use that number for something and have them write that number in some system, and then you can match those two things together. And companies do this for everything. Like, we use it at HubSpot for, well, I'll talk about that later. Google uses it in Google Search, for example. When you click on something, well, you're effectively telling Google that was a good recommendation. Netflix uses the same thing. When you watch a video all the way to the end, well, it probably is what you were looking for. Facebook does the same thing with when you click on something that has some nuances to it. Maybe we can talk about that later as well. So yeah, but this is a very common approach.
Cool, great, thank you. Next, we're going to talk about, for the specific panel that we have here, 3 different types of training data. First one is client services data, so data that's generated from customers, and Rob will talk about that, and Axiom Law and Knowable. And then Hector's going to talk about it from a user-generated standpoint at HubSpot and other marketing automation systems and other tools as well. And then David will talk about it from a simulated, especially from a self-driving car standpoint. So Rob, do you want to go ahead and kick that off?
Absolutely, thank you. So as Hector pointed out, one of the critical components of training data is having the right label. And so there's an opportunity here for a business, and Axiom Law is an example of that. We've now spun out a whole division, which is now a new company, that essentially generates that training data on contract with a client. So if you take an example of when some company buys another company, an M&A transaction, they have a very short window of time where they need to review in great detail essentially every contract that's important to that transaction, which really summarizes every contract that's important to the company that might be acquired. And so we've built over the last 5 years a really fantastic team that can do that work manually. But what that looks like is up on the screen, where you have incoming documents that on the request of the client need to be reviewed, and you need structured data as an output. So on the far right side, you see that you get like a BI dashboard. And that's very different than what you would get from a law firm, or have got from law firms in the past, which is either you go from 100 pages to 1 page, or you go from 100 pages to an opinion that says, this is not risky, right? That's not super helpful when somebody's trying to make a valuation choice. So now what we do is we actually extract this against a standard list of questions and answers, and those answers now become data elements. So what this does is a really unique way of saying, we're going to have the clients who are asking for the data as the output drive the economics that allow us to now do this at scale. So we're able to, again, off of those contracts, drive structured data that we eventually then turn into machine learning algorithms that can slowly replace the simplistic work of the attorneys in our team and move on to more and more advanced work. The two big benefits here are that obviously the client's paying for the initial extraction and the tagging, but also that you're getting a sense for what is actually important to those target customers to get from these contracts. So as opposed to guessing what the right answer is, the difference between a click and watching a video to the end, you're able to say definitively, this was really important. They were willing to pay for this up front. And so there's a benefit there. We'll talk about some of the detractions in a minute, but there's a real benefit for setting up a business model that allows you to fund the training data tagging.
Yeah, and I think one of the things you and I have talked about is the concept of standardization, right? So especially when you're working with Fortune 500 companies, they have different sort of cultures, they have different ways of approaching things. They think that whatever they're doing is probably unique and special. So how do you deal with that? Because it's sort of counterintuitive to what you're trying to build with a machine learning algorithm, just in general.
Yeah, I mean, Hector's going to talk a little bit about what a bootstrap or the initial startup phase of a truly ML-driven solution might look like. But in our case, we actually just went out and listened to clients and said, okay, what do you want to extract from this? It was a very customer service-driven, client service, white glove type solution. The problem is, as you now look at that and say, how do we build a machine learning model off of this? If the data is not standard, if you don't have the same list of answers against the same list of questions, all of a sudden those tags are irrelevant because they don't create a pattern that you can learn from. And so one of our challenges and one of our real benefits here is we're looking back on 5 years of data to identify a standard list of questions and a standard list of answers. And so when you're talking to a Fortune 500, you really can't go in and say, I think the opinion that you have here is wrong, because they're going to tell you that you're wrong. They have a lot of really smart people working there. So we go back and say, actually, over the last 5 years, or the last several hundred of these engagements, clients like you, companies like you, in the same situation have asked these questions, and they've gotten this value from asking them in this way. And so you bring back a set of insights that says, this really should be the standard starting point. But the balance to that is you can't be obstinate, especially with the large companies, because they'll just argue. But you can't be obstinate and say that you have the right answer at one point in time. You have to continuously listen and be open to creating new questions or new answers to those questions to identify additional data. So that's one of the really, really hard balances for us.
No, that makes sense. And Hector, I don't know if you guys experience anything similar to that with HubSpot.
Not the same. Like from our perspective, we control everything. So we have we generate our own data sets and all that. On the other side, so you guys have a very neat problem in the sense that your label data set is perfectly labeled. I think you get paid literally to label it, right? So that's a great place to be. It's a great business, actually. From our perspective, what we do is we are in control of the whole thing. So we have to pay ourselves in that regard. So we have to create these loops that we've been talking about. But on the other side, like, we need to make sure that these loops make sense with with the value that we're trying to provide the customer.
Yeah. One additional thought. If you approach a business model where you think that the output of the machine learning is going to be what you sell, this type of model is a really great way to bootstrap it. Meaning, if somebody is willing to pay the price that would make it profitable for a person to do the work, then you know that it's going to be profitable once you finally achieve it at scale with machine learning. And really, you're just going to drop the price, you're going to unlock more markets, you're going to unlock more use cases. So if you think that the output of a machine learning prediction is going to be what you actually sell, this is a really great way to get started.
Oh, that makes sense. And one of the other things we talked about was how do you deal with companies who feel like this is my data, I should be charging you for my data because you're using it and getting benefit from it. So how do you deal with that one?
Yeah, especially when you talk to companies with massive volumes of the target data that you have, or a user who has a large volume of that data, that is a pretty common request. Today, in the legal services space, there are standalone artificial intelligence apps that any company can buy, and they can train themselves, and they can learn against their own corpus of contracts. We actually use that at Axiom in order to try to service clients. What we found is the minute that you find a contract that was not written by that company, all of a sudden the models fall apart because they were trained on a very narrow set of structures. They were the same templates written by the same team of lawyers in the same way over and over and over. So the model was overfit to a very narrow sense. And so the obvious question is, well, how do you convince them then that they should be sharing this data across multiple additional clients? And the first answer is the data itself never leaves the company. It's the pattern, it's the learning, it's the model and the prediction capability that moves from company to company. But also, the value of training on one company's documents, be it 1 million, be it 100,000, be it 10 million, is only going to be increased by the value of the next company over and over, because you're now getting the transfer learning, you're now getting the experience of seeing different environments and different contract types, that the first client is already getting value from that. So there's a flywheel that accelerates not just for the next, but for every previous as well. And so in that sense, they are getting a big value for sharing their data. It's not monetary, but the value of that data is still embedded in the product itself.
Right, so if they're in the Fortune 500 instead of 1/500th of data, they're getting the whole thing. So
yeah, exactly.
That makes sense. And then, Hector, you and I have talked a little bit about this. I can say from my standpoint, if I'm buying a marketing automation system, I'm definitely going to try to negotiate a lower price, saying that you're using my data, but you don't. Just saying, but you guys don't really see that, or at least you on the machine learning end. Maybe the sales guys know me.
Yeah, maybe you do. I mean, I don't think we generally have that problem because, as Rob said, belonging to the neighborhood of people that have this. So we have your data, but we also have the data of everybody, and we can create better models that will help you understand your own data, right? Because you may have like a very small, most of our customers have a very small data set from a machine learning perspective, but we have many, many customers, so we can reach all that and actually give you a very, very personalized value that expands farther than what your market could be. So yeah, I think we don't have that problem because people actually get value out of it, which is a good sell point, I guess.
Fair enough, true. And actually, that's a good segue. So, Hector, do you want to talk about what HubSpot does and user-generated training data?
Right. So, the way we train data in HubSpot is, again, a little bit different to the way Rob does it. We train data that is mostly based on patterns from our customers. So one example of this could be, for example, we have send-time optimization. This is a tool that we use to recommend you the right time to send an email so the email gets engaged. So you're a marketer, you're going to send certain email to certain group of people, and different people might be in different time zones. They might read the emails at different times. Their attention might be different at different times of the day. So we have a model that figures that out for you. And the way we do this is actually by having this kind of feedback loop. We recommend these times, and as time goes by, we tie this back with the actual engagement. So was their engagement yes or no? And we tie these two things together, and then we relearn. And I think every couple of weeks or a month or something like that, we retrain with all the data we're gathering. Every company does this. It's a very common thing. You need to be extremely careful with how you define these feedback loops, because then you have things like, for example, Facebook does the same thing when they recommend you an article that you might be interested in. So they recommend you an article, you click on it, and Facebook says, OK, clicking is a good thing. And then you get clickbait, which we've all experienced, I guess. Clickbait is just somebody like me making the mistake of assuming that clicking is what you are trying to optimize for. Actually clicking leads to clickbait. So what you really, really want, actually, or I'm pretty sure what Facebook ended up, how they fixed it, was by making sure that it's not only click, but click and stay. That's probably the reason, actually, if you guys use Facebook and you check the app, they've changed the app. When you click on an article, it no longer opens Safari or Chrome. It actually stays on the app. Pretty sure, haven't talked to any of the Facebook guys about this, but I'm pretty sure the reason why they do that is so they can track how long you stay afterwards, which is a good thing, I guess. So yeah, the process is fairly different, particularly because you need to define this loop that acts as a proxy, because, for example, in this case, clicking or click and stay or whichever is being a proxy for relevancy, which you can't really measure directly.
Yeah, and again, for me as a marketing person, this is critical because it helps me understand, whether it's somebody in a different region or a different title or a different industry, when are they most likely going to be either reading my email or interested in what I have to share. And so this technology is phenomenal, and it really is starting to allow marketing people to do more one-to-one marketing, which is really just going to help with conversion and help with sales at the end of the day. So super excited to see where that goes. One question that we get a lot, and I think somebody asked it here, and that has to do with sort of the amount of data that you actually need to effectively run some of these machine learning algorithms. So I would love to see a show of hands. How many people here think they don't or will never be able to have enough data to do what they need to do? Okay, not bad. Yeah, you have plenty. But yeah, I mean, it's a big issue for people. I mean, you see and you hear about how Google, Facebook, Pitney Bowes with its geospatial information. They have so much data that they're collecting, and so many different things that they can do, or so much that they can charge other people for it. But I think what it's coming down to is you don't actually need that much data. And so, Hector, I'd love for you to kind of talk about how much data do you really need?
Right. I'm actually fairly passionate about this topic because I think there's a big misconception here. Every time people hear about deep neural networks, which are very trendy these days, and for a good reason, there seems to be a high correlation between deep neural networks and the word billions. They seem to go hand by hand. Everybody is if you want to train the cat model, you will need billions of cats, which is not really true. The way I like to think about it is that deep neural networks let you get away with just a billion cats. The deep nets, so before deep nets, most people used to use what we call shallow networks, which are basically deep nets with only one layer. And these networks are proven to be Turing complete, which effectively means that they can solve every single problem that there is, assuming that the network is large enough and there is enough data. So you can recognize cats with a shallow network. The reality is that with that, you probably would need a quadrillion kind of volume of samples, which is, that gets to be untractable. So with a deep net, you get away with just a billion. The good part of that, the good side effect of that is that if you have a problem that would normally need a million, which is tractable, and it was tractable before, it just was a lot of data, you can actually now maybe get away with just 10,000 or even 2,000. I've seen in production and a deep net for image recognition that was trained in just 2,000 samples. And it worked perfectly, high precision, high recall. But that's because it was a deep net. And the way I like to think about it is that deep nets let you, the big difference between deep neural networks and other kind of models, most of the other models, that they actually let you change them. So you define the structure of them. So in a way, you can put some of you in them. You're teaching the network some things you know about the problem. In a way, you're putting a little bit of your soul in them. Some information that you know, you can actually tell it. So for example, convolutional neural networks, which I think some people over here were talking about image recognition, so I'm assuming we're using something on the lines. Convolutional neural networks have the concept of locality. So by using a convolutional net, you are telling the neural network, the pixels that are close by, there is a certain relationship between them. So if something is green, you can expect the next one, the ones around them, be another shade of green. Recurrent neural networks basically tell the model the property of sequencing. You can use them for time series. So for example, if you're doing weather forecasting, you can say, well, I'm going to use a recurrent neural network, and I'm telling the network that this thing goes before this other one, and this one goes after, and there is this concept of sequence. And you can use this for a lot of purposes. There is the concept of embeddings that lets you transfer information from certain domains to another domain. So all these things, they're a way of putting some knowledge that you have into that. And by doing that, effectively what you're doing is just reducing the number of samples that you need. You will always be able to solve the problem if you have enough, but it gets very, very complicated. So you can just get away with much smaller thousands. I'd say if you have 2,000 samples, you're fair play to at least try.
Got it. And so one of the questions somebody asked before we started was like if they're data poor. So it could be that they either don't have enough or maybe they do have enough, or maybe the quality isn't the right kind of quality. So I know you run into, I mean, you guys, yours is very contained, so it's a little different, but.
Yeah, I mean, we're seeing pretty significant improvements in, industry-leading contract reading algorithms, and we're doing it with a few thousand examples. Part of that's because we're controlling the data, so we know it's high quality. Part of it's because it's a very niche solution, right? We're trying to essentially answer one very narrow question, which is super, super helpful.
Cool. So I think it's going to get a little loud in here, and we're going to have David now talk about self-driving cars.
All right.
You're going to make them stand up and exercise again?
No, we're all warmed up. So this is data from a challenge that we ran at Udacity for our students. We did this in conjunction with a Lyft, and the challenge is for students to use this data that we gave them to find lane lines on the road, so that when we give them a video of the road, they can identify which pixels on the road belong to the lane that they're in. So just out of curiosity, who here thinks that this data comes from a simulator? All right, couple hands. Who thinks it comes from a camera? More hands? So actually this comes from a simulator. This is the Carla simulator. It's an open source simulator that we recorded data in, and we gave it to students, and the fact that it's a little hard to even make that distinction indicates just how good simulation has got and how photorealistic simulators are now, and that really helps companies that are trying to get off the ground record lots and lots of data, because it's really expensive to put a fleet of cars on the road to go record real training data. And there are a few big advantages you get with simulators. So one is the labeling. Both Rob and Hector have talked about the importance of gathering labeled data, and the labels here are these green pixels. All of those green pixels that represent the road are in fact labels, and you could pay somebody to go by hand, and there are in fact whole companies whose business model is predicated on shipping data like this off to low-cost environments and having a human sit there and label them by hand. But that becomes really expensive, and with a simulator, you get all of that data for free, because the simulator simply tells you where the road is, and you don't have to have anybody label it by hand. So labeling is a big advantage of simulation. Another big advantage is the ability to create really interesting scenarios really quickly. So if you have a fleet of self-driving cars out on the road, they might have to drive for days and days and days before they see something really novel and interesting. Whereas in a simulator, you can program something really novel and interesting to happen, every time you fire up the simulator.
Like a drunk person walking down 6th Street at South by?
Right, like walking down 6th Street at South by Southwest. That might be a little bit of a different experience than somebody walking down the street in like suburban San Mateo, where I live. Well, so that's one of a few of the big advantages of simulation, both being able to create really interesting scenarios and then being able to get the data labeled quickly. And the improving photorealism of simulators means that we're seeing lots and lots of small companies able to jump into the autonomous vehicle space and get a lot of their initial data through simulation.
That's cool. And we work in Mountain View, so we see the Waymo cars all over the place. And the other day I saw a Waymo semi-truck driving down 101 collecting data. So, it is interesting to sort of see whether it's a hybrid model or what's happening there. I would love to kind of understand from your perspectives, from all of whether it's client data or it's simulated data or user-generated data, what are some of the flaws and hurdles that people are seeing in some of these areas? We'll start with you, Rob.
Yeah, we've kind of already touched on it, that if a client is driving the request, then there's a bit of a wrangling that has to be done to make sure that they're asking for something or they're seeing the value in something that is very standard. The flip side of that coin is, if you're doing your job right, you're trying to also grab signals from that client. So understanding if they're asking for something that's not already standard, is that because you're wrong and you're not asking for anything for the right types of information? Or are they just kind of off in their own world and asking for something that's very specific to them? The additional piece of that is also trying to understand future trends or understanding data that needs to be extracted, again, in my world, from legal contracts in advance of them being needed. So a good example would be Cambridge Analytica, GDPR, any sort of data privacy. If you went back 5 or 6 years, 7, 8 years, nobody would have had that on their standard list of questions that they wanted to know when they acquired a new company or on their day-to-day business. Now it's almost a required set of information that they need to know up to date for every contract that they have, especially if they're selling that data to third parties. They need to know what rights they've agreed to. So playing that fine balance of guiding a client to something that's standard so that you have the value of retraining and being able to deploy that model back out to the future, but also being really keenly aware that you might be missing a trend if you're not flexible enough.
Yeah. And David, you kind of talked a little bit about simulated data and not being able to, like the real folks out there seeing everything day to day, but any other?
Yeah, I mean, there are a couple big challenges with simulated data. So one still is photorealism. As good as simulators are getting, if you look really carefully at a video like that, particularly in situations where you have a lot of motion, so a person walking across the road or a car turning, you can tell that it's still computer generated. And so what you need to do really is to kind of train your model kind of initially with simulated data and then do what's called fine tuning with real data from a camera, make sure that the last data sets that a model sees are actual real camera generated images. So that's one issue. Another issue is just variety. So the great thing about simulation is you can program all this variety into it. The bad thing is you only get the variety that you program into it. And anybody who's working on self-driving cars has this library of all these crazy things that they've seen on the road. People jumping out from bushes and objects falling out of the sky and cars driving the wrong way down a divided highway. Chris Urmson was here yesterday, and he's led a few self-driving car projects. He has a great talk where he talks about a woman herding ducks across the street in Mountain View, California. You just see all these crazy things in the real world that you wouldn't even think to program into a simulator, and you really need to be out in the real world to observe what those are. And you don't just get them for free out of the simulator. So that's a big challenge.
Yeah, that makes sense. And Hector, you talked about Bootstrap already, but what about like clickbait?
Right.
You mentioned that.
First of all, the video of the dog is amazing. Like, you guys should totally check it out. It's hilarious. So in our case, we've already talked about the clickbait. So I guess you guys don't need to. I mean, yeah, when you create data, you need to make sure that your feedback loop. If you're using a proxy, so make sure that your proxy is representative of what you're actually trying to achieve, which in the case of clickbait was relevancy, and it didn't work well. But another big problem that we actually was talking to one of guys here in the audience before is bootstrapping. So particularly when you have features so you're launching a new feature and the feature has machine learning from the get-go, because quite often you can get away with not having machine learning until later on you need it, right? You have YouTube at the beginning, I'm pretty sure it didn't have machine learning, I guess. And later on, once you've gathered data, you create your model. So you're fine, you have data, you're fine. But very often you have, and we have some of those examples in HubSpot. You have, for example, we have topic recommendation where, well, we cannot give you topic recommendation if we're not recommending topics. It's like this thing needs to ship with machine learning. So bootstrapping can be very challenging. There are, I'd say, two main ways of dealing with bootstrapping. One of them is having manual labels, which is a challenge in itself. It's expensive. Is similar to what we were talking on the simulator. It doesn't necessarily have the same kind of distribution that you're going to have in production. So it doesn't necessarily actually match perfectly. So it has some challenges, but it's a good solution. There are other solutions like using multi-arm bandit. I don't know if some of you might be familiar with it, which is like like a small field in mathematics that deals with exploration exploitation. It's a good enough solution for certain cases, like block recommendation, where getting the right answer from the get-go is not as important, because you will have a lot of exploration at the beginning, which can drive the trust of your customers down, which at the end they will stop using your tool or whatever, because at the beginning it won't perform as good. So bootstrapping is a big problem. It has solutions. They're overcomable, but yeah, I'd say those are the two biggest, at least, that make me lose sleep.
Yeah. And then one of the other things we've talked about a lot about labeling, which we're going to get to, but I think we've kind of covered labeling quite a bit. But one of the other things that comes up quite a bit is the storage of this data. Like, how does that work? So how does that, David, I don't know if you want to talk about that.
Yeah, I think big data maybe is about to become, or maybe is the next big thing for autonomous vehicles. A single self-driving car loaded up with LiDAR units and cameras and radar can generate into the hundreds of terabytes of data a year. And if you think about a fleet of autonomous vehicles, you're looking at petabytes or even more. And that introduces all sorts of problems and challenges about, even logistically, how do you get that data off of the car? Do you use a wireless network in people's homes? Do you use an Ethernet transfer? Where do you store the data? Storing that data in cloud services at that size becomes prohibitively expensive. My old employer, Ford Motor Company, is turning some of their older assembly plants actually into data centers to store all of this data that's coming off the car. Privacy considerations, particularly for something like a car that is very personal and has a lot of personally identifiable information, becomes a big challenge. And labeling, which we've talked about a bunch already, is a huge challenge because you have all of this data, and a lot of it is maybe not all that interesting, and sending all of it to a human data labeler is just not scalable. There aren't enough people who label data to handle all of the data coming off of a fleet of autonomous vehicles. And so you need to figure out what are the really interesting scenarios that we want to make sure get to a human labeler so that they can get labeled, and what are all the things that happen during the day driving the car that actually aren't all that interesting, that you don't gain that much benefit out of working with, and you can maybe delete those or store them away for use later. So those are a bunch of the big challenges people are thinking about with autonomous vehicles and data.
Yeah, and I know, Rob, for you, again, because yours is pretty specific and you're working with specific customers, there's definitely some things that aren't applicable to everybody, and so you probably have even less data than most would.
Yeah, we have a whole lot less data. The major difficulty for us that's coming up is being able to transfer that learning again and understanding the different environments of different clients. But fundamentally, the data volume is much, much smaller than self-driving cars.
Yeah, so one of the things we talked about also is, and there's a ton of AI sessions out there on ethics and responsible AI and machine learning, but one thing that I'm just kind of curious about is how far is this going to go, and how much should we sort of trust the interpretation of law, for example, with AI and machine learning?
Yeah, Knowable takes a pretty strong stance. Our solution, even in its optimal state, is still going to be machine learning, providing prediction that then gets qualified by an attorney, because it's critical that this data is at the utmost of accuracy, and the only way you can do that is going through a layer review with really highly trained individuals. So for us, especially at the level of criticality of the law, and if you think about North American law as being very interpretation driven, there's very low likelihood from our point of view that we're going to be replacing lawyers with humans, with the exception of, again, read, answer, simple question.
Yeah, it makes sense. And then, David, kind of taking that a step further, you talk a lot about cross-cultural, whether it's, I'll let you talk about it, but.
Yeah, there are a lot of interesting questions with autonomous vehicles related to say, geography. If you train a self-driving car to operate in one context, can it operate in a different area? And this actually gets into a field that was originally pioneered by psychologists called transfer learning. The idea of taking something that you learn in one domain and transferring it to another domain. So if you think, for example, about here in the United States, where we drive on the right side of the road, Hector lives in Ireland, where they drive on the wrong side of the road, and you need to have different models in order to drive on the right side and the wrong side of the road. So what you might want is to have kind of a fundamental model that understands things like colors and shapes and even what the road is and what other vehicles are and what pedestrians are, because those things are all common whether you're driving on the right side or the wrong side of the road. But you might then fine-tune that kind of base model to drive, say, on the right-hand side of the road or on the left-hand side of the road, depending on what geography you're in. And if you could even think of maybe an even more divergent case, something like the US, and then driving in a country, say like India, where traffic norms are different and infrastructure quality is different. You might still have a kind of foundational model that understands some of the core concepts of what it's like to operate on the road and to recognize your environment, but then is fine-tuned to an even higher degree for different driving contexts and predicting what other drivers might do in different scenarios.
Yeah, no, that makes sense. So we're going to go ahead and open this up to questions in a little bit. We had a couple questions that came in ahead of time. There's a mic back there. But just kind of wanted to summarize. So, we've been talking about AI training data, some of the ways that we're collecting the training data, whether it's through, customers. Obviously there's a ton of other ways, whether crowdsourcing or just purchasing it as well. We talked about how these folks are actually using it and leveraging it and applying it in their sort of day-to-day lives. And how you guys might see some of this and how it might be applied to some of the things you're working on, some of the hurdles you might see, and potentially how to overcome them. So first off, I just want to thank you guys. This has been awesome. Thank you. Again, I'm super excited about it from my standpoint. So I will go ahead and take a couple of questions.
I'm so short. Okay, can you hear me? My name's Carolyn. Thank you for the session. So a really big topic in the space is around bias in data set training. So I'm curious your level of confidence using the data that you collect and use for training in the sense of it being a sort of ground truth. For example, Rob, you mentioned you hand pick tags. How confident are you that there's no errors there? And Hector, sorry, I'm so bad with names. And Hector, you mentioned sometimes you use 10,000 to 20,000 data points, and for me I sit in research, so for me I'm that's too small. But it also really depends on the population that you're looking at and the percentage. So I'm actually curious to get a better sense of if you're using 10 to 20,000 data points, what's that percentage representing of the whole?
Right. So usually,
Have a Kit Kat.
Good catch.
hopefully going to answer your question. When you do training in machine learning, you always do what we call a holdout set or test set, cross-validation set. So you will know, or you will have a good indication of how your model performs. So it's not like you're going to train the thing and say, well, it works. No, it doesn't necessarily work. It will work very often, but it's not a guarantee, first of all, that it will work. But the interesting thing is that because we can use transfer learning, which they've talked a little bit about that, you can usually, one of the ways deep nets get away with simplifying is not only by constructing a particular network with a particular shape, is by using other data sets. So for example, we have a phishing algorithm for one phishing model for one in our company. The phishing model luckily doesn't have that many labels because we don't have that many customers that try to send phishing emails. So we have a small set for that, but our model doesn't need to learn English because we can take Wikipedia or Google News or whatever to train an embedding like Word2Vec. A lot of the technical people here, I'm pretty sure, have heard of it. Lets you basically, the way I like to think about embeddings is similar to how, if you've watched The Matrix, how Neo learned Kung Fu instantly, and it was like a module. So Word2Vec in this case is a little bit like that. You just put a module down there, and now your model knows English. Great. So you don't need to learn English. Now you need to learn these other parts, but that part is already given. So for example, we have a model for email, so English doesn't need to be learned. We use an external embedding for that. But also the concept of an email doesn't need to be necessarily learned either, because we use other email problems, like for example, send time optimization problem that I think I spoke about before. So that one, we have a lot of data. So we train a model for that, and we use some of the learnings from that to the other model. So even though I don't think I should tell how many labels we have for the phishing, but it's tiny, it's very, very tiny. We can actually get away with that because we've transferred information from many other models.
Yeah. In the legal space, we definitely deal with bias on a consistent basis, partly because, and to be clear, we're in corporate law, so we're not talking about lawsuits, judgments, any sort of public trials. None of that is within our scope. We're primarily dealing with commercial relationships. So did you buy something from a major retailer? What was the price that you agreed to? What were the terms? So there's a limited set of biases that are available because we're not talking about race, gender, socioeconomic status. Any of those things are sort of out the window for us. We do see a pretty heavy centralization around the templates that large companies use. And that's because we've got more data set from them, right? We can see that they write, say, a header for a change of control, as opposed to another company that might embed it somewhere else in a different paragraph. So our way around that is to identify that, we know that that's going to be a problem. And so time after time, we're trying to identify as many varieties of these as possible. And then in terms of knowing whether it's right or not, we have this wonderful thing called a client relationship. If they don't like the results because they review it and it's wrong, we have to go back and do it again. So we have almost a built-in quality control in that these data sets are being used to make very high stress decisions, and we know that we have to be right.
Thank you for that question.
Hey,
Questions?
thanks for the session. It was really, really nice. Quick question on so a lot of times we deal with business stakeholders who feel that, creating a training data set is a non-value-added activity. What are some of the strategies that you have employed in your workplace where, you try to get the buy-in of the business stakeholders, make sure that they feel that, okay, this is a value-added activity that will help out in the long run, and get past this chicken and egg problem of sometimes, that we, the business wants to move at the speed of light, but you are, the training data set is important. So what are some of the strategies that you've employed to get past that?
Have a Kit Kat!
I'll take a first stab at that. I'm sure you've got some as well. We deal with this today because we're making the transition from a services company to a product company. And by definition, that is one of the major problems, because we'll get a client that's coming in and asking for something totally out of nowhere, and it's a valid request for that one client, but it's not going to help us learn and advance to the next client. So really what you have to do is try to find, and I'm saying this even though it's a difficult thing, identify what the incentive is of that business stakeholder. And oftentimes when it comes to somebody like sales, it's about being able to identify that they're going to have a larger market when they can provide the same service at a much lower cost, right? And really lay out the steps of saying, if you don't get me, in our case, if we don't get 5 more standard clients, we're not going to be able to get these 5 algorithms to a level that we can start reducing our cost. If we can't reduce our cost, here's this whole segment of the market that's not willing to pay our high price. And so really tying it into the things that they're concerned with is going to be the big painful part. I'm sure it's different when it comes to more user-generated data and almost like an independent cost,
Right.
because you're driving independent tests.
I actually a good.
I was just going to say, so Hector and I talked about this yesterday when we were, and for me, from a marketing standpoint, like he was asking, how can I help marketing people understand like the significance of this and what it means and why we should be paying for it and everything. So, but I'll let.
Right. So I would recommend 3 approaches. I'm going straight to give a solution. Hopefully that helps. So one of them is use the kind of feedback loop I mentioned. So that way you don't need to get any nobody needs to get you a go or no go, because you're getting it for free. The other approach is tag it manually yourself, and then that will prove the value, and from there because you will be able to get away with like 1,000 or 2,000. I know 1,000 or 2,000 sounds like a lot, but usually like in 4 hours, depending on the problem, you can get away. You can actually tag a couple of thousand. And half a day, it's painful, but like we've all done it. What was the other? Yeah, the other option I would recommend is use transfer learning. So get another data set from online, a free data set, download it, and use it. Obviously, it's not going to be perfect, but there are a lot of, particularly recently, like Google released Google data sets, I think it's called, which is basically a search engine for data sets. They also have TensorHub, which if you use TensorFlow, is literally one line, and you can put an embedding. It downloads the embedding, puts it in your graph. It's wonderful. So I would totally recommend what those 3 things. One of them is just label it yourself, just to prove a point. Create a feedback loop, so it's just for free. And the other one is to use other data sets and use transfer learning. Usually with the first 2, like your manual label plus the transfer learning, those 2 will probably do the job in many cases.
Hi, my name is Rishi Basu. I'm from the Bay Area. I had a question for David about the challenges you guys face in autonomous driving. One of them was, how do you guys deal with rain on cameras? And the second thing I had was, how do you guys deal with the crazy street signs? Like, say you're in Santa Monica, you're hosed all the time. How's the camera supposed to? How are you guys accounting for that?
All right, well, first, Kit Kat. So good questions, one about rain and another about street signs. Rain is a surprisingly big problem. There's a reason that almost all of the autonomous vehicle testing you read about is happening in Phoenix, Arizona, or Las Vegas, Nevada. Big, wide open streets, 365 days of sun, like virtually zero rain. As soon as you start to introduce inclement weather and also things like curving streets and elevation, you get all sorts of complications. And of course, self-driving cars will get there eventually. From a practical perspective, there are a few things. One is windshield wipers. Another is redundancy. So that's part of the reason that self-driving cars have so many different sensors is simply redundant coverage. And a third is actually there's a whole cottage industry of like plastics and coatings providers who are thinking like really hard about like how do we keep the lenses and the covers of sensors clean so that kind of self-cleaning or water-resistant type coatings that will clean sensors. So that's one. That's kind of the answer to rain. The answer to the question about street signs relies pretty heavily on mapping. So part of the reason that high-definition maps are so important, and actually to back up, the reason that self-driving car tests are often geofenced, as they're called, to areas like Phoenix or Las Vegas, is because those are the areas that the company running the test has gone to the trouble of mapping. And that mapping turns out to be really expensive because you're mapping down to kind of the single-digit centimeter level. And part of the reason those maps are so expensive is you want to be able to tell the sensors on the car where to look for things like traffic lights and street signs. And so in a lot of cases, even if a street sign is missing, it's on the map and the car knows it's there. So again, you have kind of a form of redundancy. It's one of the bigger challenges actually that's kind of along the same lines are potholes. Things like that really throw off a car, and actually they also cause departments of transportation to pave the roads, which screws up the maps. It's kind of all of the infrastructure forms this kind of repeating cycle where people are fixing the infrastructure and then the companies have to go back and remap, but it causes a little bit of a problem.
Thank you. Go ahead.
Cool. Very simple question, but I'm getting very different answers to that one. I'm creating my own data. So I'm using heuristics and consumer feedback to actually create the data set. When is the right time, rule of thumb, to actually plug in machine learning into that data set?
That's a great question.
Kit Kat! Oh, sorry, was a little off on that one.
Seattle.
Yeah, I can say that from the Knowable perspective, we were surprised at how little data we needed to make improvements on existing. I think it's going to be a cost benefit for you to say how much time do I want to be building this asset, and then how much time do I want to pause that to run like a proof of concept. And if you know the problems that you're trying to solve and you can rank them on complexity, obviously run the simple one first, and then maybe skip to the next one or skip a couple levels, because you're spending time and effort to test the models against your problems. I would say very, very early, especially if it's a simplistic problem, take a stab and see if you're making improvement. If not, then you don't have to go any further, right? You can keep doing that iteratively as time goes on. Hector, any rules of thumb?
I would say today, like, seriously, because not because you're going to get a great model or whatever, but you're going to be able to know, to gather feedback. Because we actually have a patent on this. One of the important things about machine learning is that you need to train with data that matches the distribution that you're going to have in production. So if you said that you're using heuristics to gather the data, which probably means that your data is going to be biased in some way. It's not 100% sure that it's going to be very, very off. So the sooner you put in production, the sooner you can ignore that data and start gathering data from your production model. So using this kind of feedback loop kind of thing. So you will start gathering information, and we do this all the time actually in HubSpot. We gather some data as we can for bootstrapping, we put it there, and we leave it 2 weeks. And 2 weeks, we scratch that model, and then we take the actual data that we gathered for those 2 weeks, and now we train a model, and those models massively outperform the old one, because you don't really need that much data. I'll talk about that in a second. You don't really need that much data, but it's much, much more important than the volume is that it matches the distribution on production. That's like the most important thing. So the other thing that you can do is that you can use transfer learning from the older data. So this is a very neat trick. So let's say you have 500 samples in those 2 weeks or 1,000 samples, like one of those tiny data sets. And what you can do is take the other data sets, that let's say it's like 100,000 samples. You can train, you can actually use the model that you used before, take a piece of that and plug it into your new model, and then you will effectively have it kickstarted. So you will have distilled the older data set and use it in your new model. You can use like variational autoencoders for these kind of things. There are many, many techniques for doing this. But basically, you can do transfer learning on the old data and then just use the new data set, even if it's tiny, combined with the two.
We just want to thank everybody for being here today. Hopefully that was helpful for everybody. So.